Okay guys, welcome again to Econ Minds, and we are still dealing with consumer theory in microeconomics. In this video we are going to talk about some other concepts in the consumer theory. First of all, we are going to talk about we are going to learn about indifference curves and its properties, and then we are going to learn about marginal rate of substitution and how we can derive marginal rate of substitution from a utility function. And then we will cover the homotheticity and also quasilinearity in preference relation. So now let's start without wasting our time. Let's first cover indifference curve and its properties. Okay, what's indifference curve first of all? Indifference curve is the combination of different goods that provide exactly the same amount of utility. Or another way we can say that indifference curve is the different combination of goods and services or commodities that provide exactly the same level of utilities. It means every point on the indifference curve provides exactly the same amount of utility. For example, every point in this U1 bar provide the same level of utility. Either it's close to x2 or close to x1, but they provide exactly the same level of utility. And also every point in U2 bar also exactly provide the same level of utility. And U3 bar, or sorry for that because I use both of them, U2 bar, but the third one is U3 bar. So all the point in U1 bar exactly the same amount of utility. All of the point in U2 bar exactly provide the same level of utility. All the point in U3 bar provide exactly the same level of utility. But different indifference curves provide different level of utility. Only the different combination of different combination of goods and services on the identical or same indifference curve provide same level of utility. But when we move to another indifference curve, so the level of utility is going to change. So here the U1 bar, U2 bar, and U3 bar are the different indifference curve that they provide utility. And higher indifference curve provide higher utility, lower indifference curve provide lower utility. But now let's talk more about the properties of indifference curve in next slide. So there are some general properties that we have for indifference curve. The first one is that the indifference curve has a downward sloping shape. It's because of the strict monotonicity that we have. What does it mean, a downward shape? Because all the points within the indifference curve are indifference. All the points that they are located in the same indifference curves, they are indifference. So that's why when we are going to use one goods more, we need to reduce the level of another goods that we use. For example, in this graph, when we are going to increase the level of x2, we need to decrease the level of x1. Or another way, if we increase the level of x1, we need to decrease the level of x2. We need to decrease the level of x2. And also, the strict monotonicity also implies that the higher indifference curve provides the higher level of utility than the lower indifference curve. And then the second properties that we have for the indifference curve is that each consumption bundle is a part of an indifference curve employed by the completeness of preference relation. So each point that we have on a specific indifference curve, they provide like indifference relationship. They provide indifference relationship. For example, the point y and the point z, which they are located in this indifference curve, they provide exactly the same level of utility. And all the point on the same indifference curve provide exactly the same level of utility. And the third properties that we have for the consumption, for the indifference curve is that two indifference curves cannot cross. Because if two indifference curves cross, they violate transitivity. For example, let's see by strong monotonicity, as we see there's two indifference curves. This indifference curve that there's the point of W, and another indifference curve that we have the point of Y. And we have Z, which is a common point or a common bundle, both in indifference curve that we have W and indifference curve that we have Y. So by a strong monotonicity, that W has higher amount of x2 and also x1, then it should be strictly preferred than Y, which have lower amount of x2 and x1. Then a strong monotonicity implies that W is strictly preferred to Y. This W bundle is strictly preferred to Y. But as Z and W, both of them are located in the same indifference curve, then we are indifference between W and Z. And also because Z and Y, they are located in the same indifference curve, so we are indifference between Z and W. So, but the thing is, when we say that W is strictly greater than Y, but again we're saying that W is indifference to Z as Z indifference to Y, based on this one, according to the transitivity, W should be also indifference to Y. But it's a contradiction with this strong monotonicity. So although based on this one, the W is indifference to Z and also Z indifference to Y, then W should be also indifference to Y. But this relationship is contradicts with this relationship, which is W is strictly preferred than Y. So that's why the two indifference curves cannot cross each other. And the fourth properties that we have for the indifference curve is the convexity to the origin. It implies by the convexity of the preference relation. So what the convexity of preference relation means, the preference relation is convex if for every x, which is a consumption bundle in consumption set of the capital X, the upper control set, which is a set of Y included in the consumption set, such that the Y is weakly preferred or at least as good as X, is convex. As you see this curve, the set of Y, which is upper contour set, is convex. Why? Because any point between Y and Z is preferred than X. So that's why it's convex. And also, as you see this indifference curve, which they are located on an indifference set, because any point on this curve, which is the X is located, so they are indifference to X. Therefore, as you see, this curve is convex to the origin. And it comes from the convexity of the axiom of preference relation, which was one of the most important axioms here. So now, let's talk about marginal rate of substitution. What is this concept for and how we can derive it? The marginal rate of substitution is the rate at which we substitute one good or one commodity with another commodity or good while the overall level of utility is being fixed. Or another way, if we explain the marginal rate of substitution is the slope of an indifference curve. Marginal rate of substitution is the slope of an indifference curve. In terms of definition, marginal rate of substitution is the rate, again, let me focus on that, is the rate at which one good can be substituted for another good while the overall level of utility is being fixed. And this marginal utility in terms of mathematical formula, like marginal rate of substitution of x1 for x2 is equal to dx2 over dx1. dx2 over dx1, it means a small change in x1, then what will happen to x2? When we bring a small change in x1, how much x2 will change? When we derive it, so it will become to the partial derivative of utility function with respect to x1 divided by the partial derivative of utility function with respect to x2. And then partial derivative of utility with respect to x1 is the marginal utility of x1, and the partial derivative of utility function with respect to x2 is the marginal utility of x2. Then simply marginal rate of substitution is the ratio of marginal utility of two goods. And the convexity to the origin of indifference curve may be interpreted as diminishing marginal rate of substitution. When we go down along the indifference curve, the marginal rate of substitution will be diminishing. Why? Because when we are going to use one product more and more, one good more and more, then the value of this product will become less and less. That's why we are going to substitute least amount of another good for having more of these goods. Because now we have a lot of these goods, so we are going to substitute least amount of another good to have more of these goods. And now let's talk about how we can derive the marginal rate of substitution of one goods for another goods mathematically. For example, suppose we have in our two goods, which is x and y, then the marginal rate of substitution of x for y is equal to the change in y in x, or if it's too small, then we can write it dy over dx. Delta y over delta x got a negative sign because when we are going to increase one good, we have to decrease another good in order to keep the level of utility fixed. Then it will be equal to the marginal utility of x divided by marginal utility of y. How we can get this one? If we have the utility function which is u, or utility as a function of x and y, we are going to totally differentiate, or we can use the total derivative. By using the total derivative, we can get the answer. So this total derivative is equal to, for example, dy, that we have dy as du, that for du we have 0. That's why we just simply write down here 0, because the change in utility is equal to 0. Then du, which is equal to 0, is equal to the partial derivative of utility with respect to x multiplied by the change in x plus the partial derivative of utility with respect to y multiplied by the change in y. Then we are going to keep the dy over dx in one side of the equality, and then we are going to move the partial derivative operation in another side of equality. Then we come up with the dy over dx, which is equal to the partial derivative of utility with respect to x and over the partial derivative of u with respect to y. The partial derivative of utility with respect to x divided by the partial derivative of utility with respect to y. As we know that the dy over dx is equal to the marginal rate of substitution based on the definition. Because when we define the marginal rate of substitution is the rate at which one good can be substituted for another good. When we are going to change one good, how will be the change in another good? When we are changing x, how will be the change in y? But here, so by the definition, dy over dx is equal to marginal rate of substitution of x for y. But what is the partial derivative of utility with respect to x and partial derivative of utility with respect to y? The partial derivative of utility with respect to x and the partial derivative of utility with respect to y are marginal utility of good x and y, respectively. Thus, dy over dx we can simply write down equal to the marginal utility of x divided by the marginal utility of y. And dy over dx is the slope of indifference curve and represent marginal rate of substitution of x for y. As we said, the marginal rate of substitution defines the slope of indifference curve. Thus, the marginal rate of substitution of x for y is equal to the marginal utility of x divided by the marginal utility of y. And now let's talk about our third topic. This term implies that preference are homothetic if indifference is invariant to the scaling up. That means if we have two consumption bundle, for example Q0 and Q1, which they are indifference, if we are going to scaling up with the same amount, for example lambda, still this relationship will be fixed, will be kept. Then if we multiplied Q0 and Q1 both with lambda, scaling up both sides with the same amount, so then our indifference curve or invariant for that. This imposes no restriction on the shape of any one indifference curves, but all indifference curves have the same shape. Those farther out from the origin are magnified version of those farther in. And marginal rate of substitution are constant along race through origin. When we are going to scaling gap, the marginal rate of substitution will not change. And homotheticity holds if the utility function is homogeneous of degree 1. It means the utility that we scale up the Q, which is the consumption bundle, with lambda is equal to lambda multiplied by U of Q, which lambda is greater than 0. It means if we change our goods, our consumption bundle, with some positive level of lambda, then our utility will also going to change by this exactly the same level of lambda. Up to increasing transformation, this is the only class of utility function with homothetic preferences. And also preferences are homothetic if and only if the utility of Q is equal to some function of VQ, function of another function, where V lambda Q is equal to lambda VQ for all lambda greater than 0. It means if we're going to positively transform this utility function, again we are going to keep the homogeneous of degree 1 here. In terms of graph or visualization, as we see here, like for example, we have two indifference curve, which is the blue and also this another color. I don't know exactly what color name is. So if we have here the first indifference curve, which is A prime and A is located, it means A prime and A are indifference because they are located exactly on the same indifference curve. When we are going to scale up both sides by double by 2, when multiply and find A bar, A prime, and find A prime, we have 4 shirts and 2 pants. If we multiply scale up by 2, then in another indifference curve, when we multiply 2 pants by another 2 pants, then is 2 multiplied by 2 will become 4 pants. And when we have like 4 shirts here, when we multiply 4 to 2, we have 6 pants. So we are going to move from A prime to B prime. And also when we are here in A, when we have 3 pants and 3 shirts, when we multiply this 3 by 2 will become 6 pants. When we multiply this 3 by 2 will become 6 pants. So we are going to move from A to B. Again, the relationship that we have between A and A prime will be kept when we are moving to B prime and B. A prime is indifference to A, then B prime is indifference to B. So it's the relationship is invariance of the scaling gap. So now let's talk about the quasi-linearity of preference relation. The quasi-linearity implies that indifference curves are all to have the same shape in the sense of being translated version of each other. Indifference is invariant to adding quantities to a particular good. Preferences are quasi-linear when respects to the ith good. If the Q0 is indifference to Q1 implies that Q0 plus lambda EI is indifference to Q1 plus lambda EI for any lambda greater than 0. And EI is the n vector with zeros in all places except the ith. In terms of the utility function, preferences are quasi-linear if and only if this relationship holds, which utility of Q is equal to some function of some another function, which is like phi of VQ, where VQ plus lambda EI is equal to VQ plus lambda for all lambda greater than 0. So now, here is the visualization of quasi-linear indifference curve, which each curve is vertically shifted copy of another one. This one is non-linear with respect to x1, but linear with respect to x2. Quasi-linear means that one linear in one good, but non-linear in one good, but linear in another good. When you look at this indifference curve, it is non-linear on x1, but linear on x2. And each curve, as you see, is the vertically shifted copy of the other one. So these are the concepts of what we talked about: indifference curve and properties, marginal rate of substitution, and homotheticity, and also quasi-linearity of preference relation. This is it for this video, and let's continue our discussion related to consumer theory, specifically utility maximization, in the next video. And hope you enjoyed this video. Thank you so much for watching, and please subscribe my YouTube channel in order to grow, and share also this video for other colleagues and fellows in order to enjoy together. See you next time, guys, with another video related to microeconomics.